All right, so the next part of this unit is an introduction to trigonometry. So we start this with some right triangle trigonometry. Um, and we're going to start with something called side ratios. So first question is, what is trigonometry? So in general, trigonometry is just the study of triangle measurements. So essentially, that's all trig is. Um, So in geometry, we're basically going to work with these three trig ratios called sine, cosine, and tangent. So each acute angle of a right triangle has the following trigonometric ratios. All right, so first one is sine. So the sine of an angle is the ratio of the leg opposite the angle to the hypotenuse. So first sine of A, so we find angle A, and it said it's the ratio of the leg opposite of the angle. So we find the leg opposite. So that's A. So sine of A is A over, because we know a ratio is fraction, so it's a ratio of the opposite to the hypotenuse. The hypotenuse is C. So sine of angle A is A, lowercase a, over C. So the sine is the ratio of those two sides. The sine of B is going to be different. It's not the same thing. So uppercase B is this angle right here. So the sine of B is the opposite. So we find the side opposite. So in this case, it's lowercase b over the hypotenuse, which is still C. So cosine is the ratio of the leg adjacent. So adjacent, just remember the word adjacent means next to. Adjacent means next to in this case. So the ratio of the leg adjacent to the angle to the hypotenuse. So cosine of A, so we start with A, the leg that's adjacent to this. So there are two sides adjacent. It's the hypotenuse and the leg, but the leg adjacent is B. So cosine of A is B over, so ratio of adjacent leg to the hypotenuse, so B over C, because again, C is still the hypotenuse. If we're talking about side B, so angle B right here, cosine of B, is the adjacent leg, which in this case, the adjacent leg to B is A, because that's next to B. So it's going to be A over C. So the cosine of A is B over C. Cosine of B is A over C. For tangent, tangent is the ratio of the leg opposite to the angle to the leg adjacent to the angle. So tangent of A. So it says opposite to adjacent. So opposite, we go opposite of this one. Opposite is A. So it's A over the adjacent leg. So the adjacent leg, remember the leg cannot be the hypotenuse. So let's write that down just so you know. So leg is not the hypotenuse. Hypotenuse. The hypotenuse is always across from the 90 and a leg are the two other sides. So it's the ratio of the leg opposite to the leg adjacent. So if it can't be C, then it's got to be B. So it's A over B. And tangent of angle B. So angle B is right here. So we want opposite, which is B. So opposite over adjacent leg, which is A. All right, so I know it looks a little confusing at first, but with some practice, you'll get used to this. So we use this little saying to remember these ratios. So what we do is SOHCAHTOA. SOHCAHTOA. So what that means is this is how we remember the ratios. So sine is opposite over hypotenuse. and that's where the SO comes from, SOH, SOH. Cosine is adjacent over hypotenuse. That's where the K comes from, cosine adjacent hypotenuse. And then TOA, tangent, is opposite over adjacent. So SOHCAHTOA, that's what we use to remember these ratios. All right, so now we want to give each trig ratio as a fraction in simplest form. So sine of A, so step one, we need to locate A. It's right here. So sine of A, let's write SOHCAHTOA off to the side so we remember SOHCAHTOA. So sine is opposite over hypotenuse. So opposite is 5. Hypotenuse is across from the 90, so hypotenuse is 13. All right, and then cosine of A. So for cosine, it's adjacent over hypotenuse. So the adjacent leg, again, the hypotenuse is still 13, so it's going to be over 13, but the adjacent leg is the one next to it, so that's 12. So cosine is the adjacent leg, which is 12 because it's next to the A. So 12 over the hypotenuse, which is 13. Tangent of A. So tangent is opposite over adjacent. So opposite, again, is 5. So 5 over the adjacent leg, which is, again, 12. All right, then we're going to look at angle C now. So angle C is right here. So sine of C, so sine is opposite over hypotenuse. So opposite is 12. The hypotenuse is still 13, that never changes. Cosine of C, so cosine is adjacent over hypotenuse, so the adjacent leg is 5 because that's next to angle C. So it's 5 over 13. And then tangent of C is, so tangent is opposite over adjacent. So again, opposite is 12. And adjacent is the leg that's next to it, which is 5. So 12 over 5. All right, so for number 2, we want sine of W. So W is right here. So sine is opposite over hypotenuse. So opposite is 12. And we have an issue because we don't have the hypotenuse. So we're missing the hypotenuse right here. So what the question is, how do we find that? Well, we're going to need to use the Pythagorean theorem. So in order to find that hypotenuse, we have to use a squared plus b squared equals c squared. So let's call the hypotenuse c. So c squared equals 9 squared plus 12 squared. Oops. And if you do all of that out, you get c squared equals 81 plus 144. So c squared equals 81 plus 144. C squared equals 225. C is the square root of 225, so C is 25. So our hypotenuse here is 25. So Pythagorean theorem is still relevant. Still have to use it sometimes to find missing sides. So sine of W is 12 over 25. To find the cosine of W, so again, cosine is adjacent over hypotenuse, so the adjacent leg is 9, because that's next to angle W, so 9 over the hypotenuse, which is 25. All right, and then finally, tangent of W is, so tangent is opposite. Tangent is opposite over adjacent. So opposite is 12 again. I didn't even realize I changed the color there. Let's try to change it back. So 12 over, so opposite over adjacent. 12 is opposite, adjacent is 9. so 12 over 9. Now it did say to write this in simplest form. So simplest form means that it's reduced. So far we haven't really run into any issues with that. But now we did, because 12 over 9, we can reduce that. So reduce. Let's get that E in there. So we're reducing this. We're going to divide 12 and 9 by 3. And if we do that, we get 4 over 3. So that's the correct answer to that one. All right, so sine of x now. So now we're looking at angle x. So sine of x is, sine is opposite over hypotenuse, so we need to find angle x. It's right there. Opposite of angle x, go across the triangle, it's 9. So 9 over the hypotenuse, which is still 25. Cosine of x. So cosine is adjacent over hypotenuse. So cosine, the adjacent leg, is 12 over the hypotenuse, which is, again, still 25. And then tangent is opposite over adjacent. So opposite is 9 over adjacent, which is 12. And again, the same thing. We're going to reduce this the same way we did with this one. So it's going to become 3 over 4. All right. So that's it for number 2. Let's now do number 3. I'm going to erase this in case we need the room. So I accidentally erased that. All right. So for number 3, let's just start with sine of L. So sine of L, angle L is right there. So sine is opposite over hypotenuse. So opposite is over here. We're missing that side. So we need to use the Pythagorean theorem. So let's call that side A. That's a leg. The hypotenuse is 34. So let's do A squared plus the other leg squared, which is 16, equals C squared. So the hypotenuse squared. So 16 squared is 256. So A squared plus 256 equals 34 squared, which is going to be a big number, 1,156. So then if you subtract 256 from both sides, you get A squared equals 900. I don't have a lot of room here, but if you take the square root of 900, you get 30. So our our missing leg here is 30. So sine of L, we're doing opposite over hypotenuse, so it's 30 over the hypotenuse, which is 34. And that we can reduce. So if we reduce that, we can reduce it by 2. And we get 15 over 7. So I'm going to erase that and write 15 over 7 just because I don't have a lot of room. So this one is 15 over 17. I'm sorry, I keep saying 7, but it's actually 17. So 15 over 17. Cosine of L is, cosine is adjacent over hypotenuse, so the adjacent side to L. The adjacent leg is 16 over the hypotenuse, which is 34. And if we reduce that, what we get is 8 over 17. Just divide both by 2, and we get 8 over 17 for that one. All right, and tangent of L. So tangent is opposite over adjacent. So opposite of L is 30. Adjacent to L is 16. If we reduce that, we get 15. So reduce it by 2 again. Divide each by 2, and you get 15 over 8. All right, so now we look at angle M. So now we're looking at angle M. The sine of M is sine is opposite over hypotenuse. So opposite of M is 16. So 16 over the hypotenuse, which is 34. And again, we're going to reduce that by 2. So 16 over 34 is equal to 8 over 17. Cosine of M is, so cosine is adjacent. So 30 over the hypotenuse, which is 34. And again, we're going to reduce that by 2. So we get 15 over 17. And then last one, tangent of M. Tangent is opposite over adjacent. So opposite of M is 16 and adjacent is 30. So 16 over 30. And again, we're going to reduce that by 2. 16 over 30 is equal to 8 over 15. And that's it for side ratios, sine, cosine, and tangent.